Hello everyone, and welcome to this episode of the 909 Rimshot build. And in this episode, we will continue with Frontpanel. And to do so, let's start by bringing up the design of the board, or the PCB again. Alright, so I wanted to show the dimensions here of the PCB. This is something that we established earlier in the episode 3, I think, floor planning. And let's just highlight the mechanical dimensions here. Here we have a center point defined. We have 50 millimeters from the left board edge, and we have 50 millimeters from the top, and this is the center. And we will use that as a reference when we make the front panel. Every dimension to the pots and to the key and to the jacks, they are referenced against this reference point here. Okay, so let's close this one. And we will create another one. New project. And we will place it side by side with the 909 Rimshot main PCB. Like so. And we open the PCB editor. So here we have a blank sheet that we can use for the front panel. All right, before we start, I would like to mention a couple of words about the dimensions of the front panel. And as you can see here on Doper's homepage, they say that 3U equals 133.4 millimeter. But in order to make it fit, if you have a card cage that has rails on the top and bottom, which basically everyone has nowadays, the final height is recommended to be 128.5 millimeter. And I use a slightly different dimension. I use 128.0 millimeters. And the reason for that is one of my DIY cases, the dimensions didn't get completely correct. So in order to make the modules fit perfectly, I had to make them a half a millimeter shorter. But that is not a problem for professional built cases or if you are DIY something from using pre-made rails. You can see here that there's a difference between the calculated module width and the actual module width. So in our case, we are using a 6 HP, so our panel should be 30 millimeter. All right, so we are back into the PCB layout again. So we are going to start designing the front panel, and we will start with a board outline, which means that we will select edge cuts, and we want to draw a rectangle that is 30 by 28. So this is what our panel will look like. And the next step is to basically copy the dimensions from the drawing I showed you earlier on the main PCB. So let's start doing that. And in this case, we are not using 50 millimeters height, of course, because the PCB was 100 millimeters and half of that is 50. But half of 128 millimeter is 64 millimeters, so we will use that. So this intersection here, this is the new reference point for the panel, and it will match perfectly with the PCB, and the PCB will be centered between the top and bottom. So let's continue with the rest of the dimensions. For example, we have the jacks down here. And we have the center point for the first pot. And for the second pot. And we have the jacks. And finally the button. Okay. So let's have a look at what we have done so far. So we have a panel, but we don't have any holes in it yet. And there are a couple of different ways of doing this. One way is to use the edge cuts layers here, and we can draw different shapes, holes and whatnot. And we can place them into the design like this, and that will produce a hole, and that is a perfectly valid way of doing it. But I prefer to make footprints, because I probably want to reuse. If I make something for a Tonkicon jack or for a pot, then I will probably want to reuse that in other designs. So it makes sense to make a footprint for it. And the way I do that is to go into the footprint editor. And what I will do here is to create a new library. That will be global, of course, since I'm going to reuse it for a lot of other stuff. Like so. And then we have this library over here. And we can start populating that with footprints. Okay, so we will start by making the hole for the pot. And we call that alpha, like so. Move this a little bit. First, what we want to do here is to add a pad for the hole, and the type should be non-plated through hole, mechanical. And we will actually have the same pad shape as the hole shape. So, and the dimension for the pot is 7.2 millimeters. And we do the same here, like so. Like this. And this reference on the silk print, you can remove that or mark it as invisible. And you do that by removing this tick here. Okay, so now we have created our first footprint. Let's save that. And you can see that we have it here in our library now. And let's continue with another one. In this case, we want to have the Tonkicon jack. And we do the same thing here. We can make that invisible. And we add a pad. And in this case, it should be 6.2 millimeters. And let's save that. Okay, so our library, we have two footprints here. And we will need one more for, or at least two more, I would say. One more for the cherry key, the key top. Okay, we can change the visibility of that. So the dimensions for the cherry key is, let me see, 19 times 19 millimeters. So what we are going to do here is we are going to draw that in the edge cuts using a rectangle like this. So, and what I want to do now is to center that around the cross section here. So we will move it. That is okay. We can do some measurements. 9.5 millimeters from the center. Yep, that's correct. Same here. 9.5, 9.5, and 9.5. Okay, so we are in the center here. What you can do if you want is to add a sort of cross here to make the placement easier. So we can do that as well. So we will just make draw a small cross here. Okay, so I think that's it. Let's save that. Okay, so let's continue with the last one. And that is the hole for the screws. Before we continue, I would like to show one thing here from a manufacturer called Schroff. This is a standard called Eurocode, and that is basically the same standard that Doepfer have derived the Eurorack standard from. And so the dimensions of the panel, and they look very familiar. This says that 3U is 128.4, but that is basically almost the same as the figure from the Doper side. So what I wanted to show here is the dimensions of the hole in the front panel that Schroff are using. These are the ones that I have sort of copied. So the dimensions here, basically it's 3.3 millimeter height, and the width is 5.9 millimeter, and the placement is 3 millimeter from the upper or lower edge of the panel, and 7.45 or 7.5 millimeters from the left side or the right side, depending on which location you have the hole for the screws. So that is what I'm going to use. Okay, we are back in the footprint editor, and we create a new footprint, and we can call that screw hole 3.3 5.9. All right, so what we are going to do here is to create one pad, and this one will actually be a through hole, and we will make an oval shape like so, and the pad size should be 7.4 times 4.8, and the hole shape should be 5.9 times 3.3, and then we have something that looks like this. And place it, make sure that we place it in the center. And I also mentioned that we want to place this 3 millimeters from the upper or lower edge of the front panel, and 7.5 millimeters from the left or right edge. So I will actually add a couple of brackets here to make it easy to place this in the correct position. And I do that by using the user comments again. And but first of all, I need to have the dimensions. 3 millimeters like this, and we have 7.5 millimeters. Okay, so now I have the dimensions, and the reason I'm doing this, it will be clear in a second. Okay, so what I've done here is 2 brackets that will align with the board corner of the PCB, and depending on if you rotate this, then you can place it in the upper or lower part of the front panel. I will show you later what I mean when I add this footprint to the actual design. All right, so I think we're done here. Let's save this. Can make a check. Everything's okay. All right, let's go back to the PCB editor. And here we have our design again. So let's add some footprints. And then we can go down to our library here, my Eurorack panel stuff. That was the footprint library that we created. And we want to add the alpha pot hole for that, like that. And we need a second one. One thing I want to mention here is that you can actually add a lot of things to your footprints. For example, if you want to have a scale here at the pot, or you want to have a sort of rendition of the knob itself. Let's say that we have a 16 millimeter knob, then you can have a ring outside here with 60 millimeters that shows how much of the panel that is actually covered by the knob itself. So you can place the text on the front panel in the correct position. There are a lot of things you can do here, but I am just showing the simplest version here in this tutorial. Okay, so now we have the pots, and we can look at that in the 3D viewer. Here you can see the holes. Okay, so the next step is to add the Thonkycon jacks, I think. So let's do that. Thonkycon. We do the same thing here. Make sure that they are properly aligned. Like so. We can save that. Yeah, it's starting to look like a panel, actually. All right, next step is the cherry key. And here you can see it's quite convenient to have that cross mark like so. Let's have a look at that. Yeah, that looks okay. And finally we have the screw holes for the panel. Okay, so this looks a little bit messy, right? First of all, we have I forgot to turn off the reference designators here, and that's where we can actually do that. So let's have a look at this. This is not right, so let's fix that. You see I aligned it to the wrong cross here, or edge. So it's always, what I wanted to show here is that it's always good to look at the 3D view now and then, just to check that everything is correctly done. And yeah, this is what the front panel looks like. And the last thing we need to do is to add some text, of course, for the jacks and the pots, and maybe some kind of label for the module. Let me show you how that is done. First of all, you have to select the correct silk screen, and in our case this is the front silk screen that we are going to use. And then we can add some text, for example trig in, and I think we want to have the text something like 1.3 maybe. Let's see how that looks. This is basically how you do it. I will show you another thing, and that is the font I'm using is kind of Roland inspired or specific. And it's actually Truetype font that I have installed. It's called JX8P, and it looks like this. When and this feature that you can use a custom font or a font that is defined in your system, that is something that is specific for KiCad 7 and later releases. So if you are still using an older version of KiCad, you cannot do this. In that case, you have to use the default KiCad font. All right, so I will put a link in the description to where you can download this font if you like to use it. So yeah, basically this is how I make my front panels for Eurorack modules. I will finish this up, and then we will have a quick look at generating the manufacturing files. Okay, so this is what the design looks like when it's finished. And I added the logo, and I also use a square or a box around the output, just to mark that as that it is a output signal. And I'm not completely happy with this. I think I have to reconsider placing the name of the module like this. I've done it like this on the other modules I've done so far, but maybe this is not a super good idea. What I would like to do is maybe to move it down here, okay, like this. And of course I would like to call it 909 RS for Rimshot. Like so maybe this is a nicer way of doing it. Okay, so let's have a look at how to produce the manufacturing files. And it's very simple. We'll just do a DRC check, save that, and then we press the fabrication toolkit. And then we have the Gerber files, and that is all that we need for this. What you need to do is to take this to your preferred PCB manufacturer and order the PCBs. And while you are waiting for the PCBs to show up, there is actually a trick that you can use to get a sort of prototype front panel that you can use your 3D printer to print one if you have a 3D printer. All right, so the way of doing this is to export a step file. Step is a file format for 3D models, and unfortunately or at least my 3D printer does not accept the step format right away. So what I have to do is to use a 3D CAD program. And in my case, I'm using FreeCad for this. Okay, so here we are in FreeCAD. All I need to do now is to import our step file. And this is what it looks like in the CAD. As you can see, we are losing the print or the labels or silk print. But this is okay for 3D printing. So what I will do now is to export this as STL file. Like this. Okay, so now we are in my slicer program. That is a program this one is specific for Prusa, or you can use it for other 3D printers as well. But since I have a Prusa printer, this is the one I'm sort of using. And what we can do now is to import the STL file. And here you can see the front panel placed on the print bed. And what I like to do is to use this is the front side, and I want that to look nice, so I place that towards the print bed. That is the simplest way of doing it, like so. And now we can select a nice. I have this special profile here where I can print I print the first layer very slowly, so it will look nice. And I will print in PLA, so that's that. And here we have it sliced, and I will save that to my USB stick, and we can put that in the printer. The 3D printed part might need a bit of cleanup, so the pots and jack fit into the holes properly. So I'm using a deburring tool for that. In the next episode, we will assemble the PCB and put everything together, so stay tuned for that. And as always, take care, and I'll see you in the next episode. Goodbye.